Hello everyone! Have you ever wondered how we can predict everything from real estate prices to stock market trends with astonishing accuracy? Today, we're diving into the fascinating world of regression models in machine learning. A regression model is a supervised machine learning technique used to predict continuous values based on input features by learning relationships from labeled training data. These models aim to establish a relationship between independent variables, features, and a dependent variable target to make predictions. Imagine you have data about houses, their sizes in square feet, and their prices in dollars. Regression looks at this data and learns how the size of a house influences its price. Once trained, the model can predict the price of a new house just by knowing its size. Key characteristics of regression models. Continuous predictions. Unlike classification models that predict discrete categories, regression models predict continuous numeric values. For instance, they can forecast house prices, stock prices, temperature readings, or sales revenue. Target variable. In regression, the variable being predicted, the dependent variable, is typically continuous. It represents measurable quantities such as prices, scores, or measurements. Predictive features. Regression models utilize one or more independent variables, features, to make predictions. These features can be numerical, categorical, or a mix of both. Supervised learning. Regression falls under supervised learning, requiring labeled training data where the actual values of the target variable are provided. Evaluation metrics. Common metrics used to evaluate regression models include mean squared error (MSE), root mean squared error (RMSE), mean absolute error (MAE), R-squared, coefficient of determination, and others. These metrics assess how accurately the model predicts numerical outcomes based on the training data. Types of regression models. Linear regression. This model assumes a straight-line relationship between independent variables and the dependent variable, aiming to fit a linear function to the data. Polynomial regression. Extending linear regression, polynomial regression fits a polynomial function to capture more complex relationships in the data. Regularized regression, ridge and lasso regression, variants of linear regression that integrate regularization techniques to prevent overfitting and enhance model robustness. Support vector regression. SVR uses support vector machines to find a hyperplane that maximizes the margin between data points while minimizing prediction errors in regression tasks. Decision tree. This model constructs a tree-like structure to predict the target variable based on a sequence of decision rules derived from the data. Random forest. An ensemble learning technique that combines multiple decision trees to achieve higher predictive accuracy in regression tasks. Gradient boosting. This method builds a series of decision trees sequentially, where each subsequent tree corrects the errors of the previous ones, leading to improved prediction accuracy in regression problems. Here are a few examples where regression machine learning models are used. House price prediction. Estimating the price of a property based on features like location, size, number of bedrooms, etc. Stock market forecasting. Predicting future stock prices based on historical data and market indicators. Sales forecasting. estimating future sales for a business based on past performance, trends, and external factors. Healthcare cost estimation, predicting medical expenses for patients based on demographics, diagnoses, and treatment history. Energy consumption prediction, forecasting electricity usage based on historical consumption data, weather conditions, and seasonal patterns. Regression models are widely used in various domains for predicting continuous numeric values. By leveraging machine learning techniques and historical data, organizations can make informed decisions, forecast trends, and optimize processes. I trust you found this video helpful. Thank you.